So today we're going to be talking about Unit 2, Module 2, Decomposition, Lesson 2, Custom Functions. So now we're going to get to some of the real fun stuff that we can do in Python. So first, custom functions allow you to write your own functions, avoid using repetitive code. These functions can be executed anywhere in a script and named anything you like. In fact, they can be executed from other scripts. You can create a whole library of custom functions for yourself. We've talked about functions before. We've used the built-in ones like the length, len, print, input, str, which stands for convert to string, int, which stands for convert to integer, random int, which is a random number, range, which we've talked a lot about extensively in the last couple lessons. Calling these functions has been fundamental to most of the examples. A function call typically takes one or more parameter. So if you use the print function, you have to put in a string literal in quotes or some variable that's a string as an argument into that function. So when it looks at the function, when Python looks at the function definition, it knows how to map that to the parameter that is inside the definition of the function. Before a function can be called, though, we have to define it. Every function we've used so far has been defined inside of the Python library or the EarSketch library, so you haven't had to define anything. But we're going to start defining our own. So here is the basic structure for defining a function. First, you have the word definition, def, and then you have some name for your function. And then we're going to have as many parameters as you want. So I wrote 2 here, but you can have as many parameters as you want. And then at the end, you have to have the colon face. If you forget the colon face, you know, this upside down sad colon face, if you forget the colon face, then you cannot make this work. You're going to get an error. So that colon has to be there with the end of the parentheses. Then tabbed in, you have to make sure this is tabbed in. You have your first command, and then you have your second command, and so forth and so forth. So this is your total definition of your function. When you're ready to use your function, you have to call it using the function name, and then you're going to put in your arguments. This is the numbers that you might put in. Just like with fit media and with the set effect function, we added in our track number, our song title, our start measure, our end measure, the starting values, and all that different things that we entered in as arguments into our function name, which then maps to the parameters. So here's an example, looking at EarSketch. We defined a function, called it my function, for lack of a better term. Used some good variable names in here, start measure and end measure. And then we have our colon, looks kind of like a sad face. And then we have our fit media command, it's our first command, and it uses the parameter start measure and the parameter end measure. And then this fit media command uses the start measure and end measure parameter. Then down here, when we're ready to use it, we call the function, and it starts at 1 and ends at 17. So the way the computer flows with this is first, when it runs, it reads this definition and remembers the definition. Then it comes to the first command. The first command says, do this thing called my function with 2 arguments. So it goes up and looks in memory to see if it can find something called my function that has 2 parameters. So it remembers, oh yeah, I got this thing up here. So it adds in 1 for start measure, and now start measure has the value of 1. It's created that in memory for us, and measure has a value of 17. It calls this command with a 1 and a 17. It calls this command with a 1 and a 17, and then the function drops out of memory. It's not there anymore. So start measure isn't there anymore, end measure isn't there anymore. And we come back to the end of this line, and then if there were more lines of code, we would move on. So once the function is called, the function becomes alive in its own memory space, and this memory space is called scope. This is a really important computer science topic. The scope of a function and the variables contained are encapsulated. So all the data that is in the function is kept within that function. So its parameter variables are automatically initialized as you send the arguments into it from your function call. Once that method has finished executing, or the function is finished executing, then all of that data comes out of memory and is what's called garbage collected. So it doesn't have any interference. Why is that important? Well, when you're defining your functions, most times your users don't see that part of the code. Like in ear sketch with set media, you don't know exactly what variables they used as parameters when they define the set media function. All you know is that when you use set media, you have to put in a certain number and certain kinds of values into the set media function. So if you happen to, let's say, use the variable start measure, and they happen to use the variable start measure, their variable start measure will have nothing to do with yours. Totally separate, because the function has encapsulated their variables and keeps it separate from your variables. And each function may use some variable called start measure, and they're all separate. They're all kept encapsulated to that function, and that's really important in computer science because none of this would work without that. So here's another example. We have a function that is well named this time. It's called add section. So clearly we're going to add a section. It has 3 parameters: lead clip, start, and end. So the lead clip is some song clip that we're going to send to it. The start would be the starting measure. The ending would be the ending measure. It has a lead clip, which is our leading song, and it's on track 1, and it starts and ends. And then we have 2 bass lines on track 2 and track 3 with the same start and end. So this is really building an entire section based upon whatever lead clip that we built in there. So we're following this structure where we're doing add a section from measures 1 through 5, and then we're going to go from 5 to 9, and then 9 to 13. This is that ABA format. So we're adding in the same song into both tracks. So this function is doing a lot of work for us. So that's one way of approaching that ABA, where you pick what clip you want to put in as the lead track and you keep the same bass track. But suppose you want to do something a little bit more complicated like we did. You can create more functions for that. Here's what that looks like visually. You have your drum track that kind of stays the same throughout, and then we have our first couple measures, our second group of measures, and our third group of measures. So it's A, B, A, and this is what it sounds like. So now we can see it switched over to B. Same drum beat all the way throughout though. Okay. So the code for that looks very similar to what we did in the past. This is the code for that. Then we had our assignment from the last section where we did our section A and section B. And we had this section of code that repeated. So all we did now is take that section of code and put it into blocks. So we have a definition for a function called section A, and it has 2 parameters, start measure and end measure. And then we have a section B with a start measure and end measure. And we just copied and pasted the code that was section A and section B. So we didn't need to do section A twice. We now can just call the function twice. So here we have section A called once, and here we have section A called again. And we're just putting in a different start measure and end measure. And the only thing I don't like still about this is that this set effect is still sitting in here. And we're going to come back to that and kind of come up with a better way of doing that. Because really what's happening is when we call function A, it calls this set effect for the entire line of the music. It goes through the entire track 4. When we call it again, essentially what we're doing is overwriting what we just did before with the same information. It's redundant, it's unnecessary. So we're going to refactor that later, which means we're going to take that information and move it out into its own function. So the other thing we can do, though, is deal with return statements. That's when information is sent back from the function. So one of the commands we looked at was input. So many of those functions return the value, just like input returned the value, and then you can do something with that expression. I want to take a look at a new version of input. It's called read input, and what's nice about this is we can put a prompt into it. So that way the user kind of knows what we want them to type in, and they knows what they want us to say. So this says select a clip between 10 and 46. When we run this command, it will put up that prompt with a little text box, and the person will type in a number, and that'll get stored here. Remember though, it comes in as a string, so we're going to have to convert that clip number to an integer if we want to go ahead and use that using some methodology. So we can take that idea of our read function, our input read function, and use that inside of other functions. Or we can take our set effect with our delay in there and pull that out of the other function. And this is called method decomposition. When we take methods and we use other methods inside those methods in order to make them work better, or we take a method that's kind of big and complicated, we break it up into smaller chunks, so that way it just does what we expect it to do. So if we go back and take our code and look at it a little bit, we can pull this set effect out, let's say, for example, and let's say I wanted to kind of put it in section B. We're not going to leave it there, but for right now, let's say I want to put it in section B. So that way it only happens one time and not twice. And I'm also going to add in my input statement. So here I have my delay value. I created a new variable. I can call it anything I want. I could call it monkey if I wanted to. And I'm going to cast it as an integer, which means I'm going to force it from a string to an integer. I'm going to read that information, and this is the prompt I'm going to give the person. Enter a number for a delay effect between 0 and 4,000. So when you run this, you'll get that information on the screen. Then the other thing I want to do is set my effect here. I've moved it from this function A to this function B, and I'm going to set the effect, and I'm going to use the variable here instead of putting in a 500 that has the delay value. So let's see what that looks like in EarSketch. So here we are in EarSketch. We have the code set up, ready to go. I'm just going to hit run, move this down here and hit run so we can see it go. And look, there it is. There's the prompt. Enter a number for a delay. I'm going to enter a nice number here. Let's say 567. That sounds good. Click OK. And then it runs the code for me and puts in my delay down here. Right here we can see it's 567. There's no number there, but that's kind of where it is. And it did all of my same measures that we did before. We can even hit play. It sounds a little different now that our delay is a little bit off. So if we don't like it, we can run it again and put in a different delay. Let's put in something really drastic. Let's put in 1,000 just so we can really hear that effect and see what it's doing. Okay, so by modifying that delay effect, we can change the sound that we're getting here. But I still am not crazy about this because really, this is section B of the music. And the delay, the set effect delay, happens for the entire track of 4. It's not just a section of it, it's the whole track. So really what I want to do is I want to create another function. So we're going to refactor this. So we're going to say, let's put it down here, out of the way. And I'm going to say another definition, and I'm going to call it my effects. And we don't need any parameters for this for right now. We're going to tab in, and all I'm going to do is take this command and put it there, and I'm going to take this command and put it there. So now I have refactored this, and I can't forget my colon for my little sad face there. So now I have refactored this, and I've pulled out the information for my effects and left that all by itself. But I got to do one last thing. I have to call it. So let's call it my effects, and it has to happen after we build the song. So this builds the song, and this sets the effects. So we shouldn't notice much of a difference when we run it, because all we did was change and refactored it. So this should run exactly the same. And you can see absolutely runs exactly the same. So why do you want to do this? Well, refactoring this makes this cleaner and clearer as to what's going on. This is setting section A, this is setting section B, and this is setting the effect for the entire song. So we got everything separated out, and it makes a lot more sense when we read it. And furthermore, if we wanted to change the effect, we can change that pretty easily. We don't have to worry about messing with what section's it in. Is it going to repeat it all? So it makes it a lot cleaner by refactoring that and pulling that out. So it is time for your challenge, your assignment. I would like you to take your ABA form song from the last lesson, and I would like you to refactor it into using functions. So take your repeated sections and define some functions for them. So you're going to have a section A and a section B, and you're going to write the code to make those repeat. I'd also like you to add in a read input function to use in one of your functions to get input for the user. So you might want to think about taking that set effect that you have somewhere in there and pulling that out into a third function and calling it my effects. So that's all separate from everything else. So go ahead and do that. If you need any help with the project, let me know. And never stop coding. See you next lesson.